As you can see, the instrument is extremely rugged and specifically designed for rough handling in field operations. Here in Australia, the ambient temperature can frequently exceed 40 degrees centigrade, and the temperature within a communication hut can approach 50 degrees. All of the measurement specifications are guaranteed for an operating temperature range from minus 10 degrees centigrade to plus 50 degrees centigrade, with battery operation specified from 0 to 50 degrees. This is a significant advantage over other products on the market. And more importantly, none of the units have any fans or vent holes, minimizing the ingress of dust and dirt in harsh environments. This is amazing, having an instrument that can maintain such great specifications and incredible temperature stability without any external cooling required. For those of us operating in secure or signal-sensitive environments, the analyzers are also incredibly quiet. Make sure you watch the interference and surveillance chapter on this DVD, where we'll cover this in more detail. The battery lasts for a surprising 4 hours under normal conditions and 3 hours with the tracking generator active. Best of all, the unit can continue to be used while the battery is being charged, using either the mains charger supplied or the optional 12-volt cigarette lighter adapter lead, making it ideal for mobile operation or recharging while travelling between jobs. What's especially impressive is the sensitivity. Spread spectrum transmissions, such as from this 3G mobile phone base station, Wi-Fi links and satellite downlinks can produce incredibly low levels of received signal power. But these analyzers typically have a noise floor of around minus 135 dBm, and that's without a preamplifier. With the optional built-in preamplifier turned on, it's more like minus 150 dBm. That's incredible for a handheld analyzer and makes field strength or interference measurements of weak signals incredibly easy, as you'll see later. On the top panel, we have the main RF input, the DC jack for externally powering the instrument or charging the internal battery, a small USB connector for connecting the instrument to a PC, a large USB socket for a USB memory stick, audio headphone out for listening to demodulated audio, an Ethernet connector to connect the instrument to a local area network, an RF output socket if you have the internal tracking generator option installed, a probe power socket for connecting an active RF probe, a dual-purpose BNC socket for connecting an external 10 MHz reference clock or externally triggering the spectrum analyzer. And even though the instrument has a built-in GPS receiver and internal antenna, you can also connect an external GPS antenna to this socket here. Here's the instrument's power button. Just press that to toggle the instrument on and off. And to the right are a range of function keys for setting parameters such as the frequency, span, amplitude, bandwidth, etc. And press the shift button for functions such as save and recall, adjusting display settings, the sweep time, etc. As with most Agilent instruments, there are 3 ways of adjusting a value, using the numeric keypad, the up-down arrow keys, or by turning the knob. If we want to put a marker on the signal, just press the marker button. And you'll see to the right of the display, there are 7 soft keys, the meaning of which changes depending on which function key we have pressed. Now here's something we were particularly impressed with. Everyone involved with satellite receivers will be familiar with the problems associated with DC power on the RF cable, typically to supply power to the LNB at the receiving dish. You'll be pleased to hear that there's a built-in DC block that will handle up to 50 volts of DC on the center of the coax. This will save many embarrassing and costly situations where a satellite feed with DC on the center pin is inadvertently connected to an analyzer. The color TFT display is especially bright and ideal for indoor and murky outdoor situations. But it's also a transflective display, meaning that in bright sunlight it works especially well. In fact, the brighter the sunlight, the better the display. By default, when you first turn on the analyzer, the built-in ambient light sensor is active, and the unit will automatically adjust the display's backlighting to save battery power when appropriate. But for the purposes of this training course, we've turned off this automatic feature and set the backlight level manually. This is done by pressing the Shift and System button, screen setting, and setting the brightness to manual. One more thing we should cover before we start making measurements is the purpose of the green Preset button. As with most Agilent instruments, pressing this button resets the instrument to a predefined factory default state and is highly recommended before you start making a new measurement. But Pressing and holding this button for more than a second performs another very useful function, that of instantly putting the instrument to sleep, saving battery life, whilst retaining all of the instrument's settings. To bring the instrument back to life after putting it to sleep, just press the green preset button again briefly. The instrument will turn back on without having to go through the normal boot up process and with all your previous settings still active. If you'd like further information on these products, including demonstration guides, operating manuals or application notes, please visit the website shown below.